Okay, so here we go. We are going to solve this system of equations by using the row reduction method, okay? And so the first step is to write it as an augmented matrix. So that's going to be my first step, okay? So I'm going to write my augmented matrix. And our goal is to have it look like this. And whatever numbers are here, these are going to be my answers. Okay, so how do I get it to look like this? And so I'm going to focus on piece by piece, okay? And here's my recommendation for you. When you first start these, it doesn't necessarily have to go this way, but I'm going to work top down. I'm going to get this to be 1, and I want it to be 1. That's already 1, so I'm good. So what could I do to get this to equal 0? So what's the row operation that I can perform? So I'm going to have to use a combination of 2 rows and some multiplication. And so the idea is, how can I maybe either work with 2 rows, work with the row that I have. So this is a little open-ended as to what you can do. There's not one exact process that works for this. So what I see here is, if I take row 1 and multiply it by -2 and add it to row 2, this will create my new row 2. Okay? The only thing that's being replaced is row 2. Okay? So I'm going to take -2 times row 1. Okay? So follow along here. I'm going to take -2 times row 1. So -2 times row 1 is -2. And then we have -2 times 2 is -4. Let me change the color here real quick. And then I have the divider, and -2 times -1 is 2. And then I'm going to add that with row 2, which is 2, 5, and -4. So this piece right here was -2, row 1. This piece right here is row 2. I'm adding them together. And so my result is going to be 0, 1, -2. So I take what I've done here, and I'm going to rewrite what I've done so far with the matrix. And so row 1 was not changed. Even though I used it to manipulate row 2, it was not changed. Okay, so I keep it the way it is. And now I take this piece, and that's my new row 2. So I have 0, 1, -2. Okay, so now, where do we go from here? I'm looking at what my goal is. My goal is to get 1, 0, 0, 1. I have 1, 0, and the way this problem worked out nicely, this guy is a 1. So now I have this 2 that I need to turn into a 0. So how can I maybe use this row to combine it with the top so this cancels out? Here's the importance of working top down. Now that this piece is 0, anytime I add to the first row, this number's not going to change. And that's why it's important to get this piece to be 0, and so you're not changing any of the work that you've done. So to adjust this number right here, I need to make it 0. Okay, so I know if I take -2 times row 2, add it to row 1, that's going to be my new row 1. That's going to cause this 2 right here to become 0. Okay, so -2 times row 2 is going to be 0, -2, 4. So this was -2 times row 2. Row 1 is 1, 2, -1. So now I add these guys together, and I get 1, 0, 3. And this is going to help me create that new row. So notice, I manipulated row 1. So this is going to become my new row 1. Row 2 was used to manipulate row 1, but I'm not going to change it. And so now I've got my goal. I've got my identity matrix, so I can say x is equal to 3 and y is equal to -2. And if we go back to our original problem and plug those in, they will both work. Okay? So this is using a row reduction method to solve a system. So we're going to do some of this stuff by hand, and some of it we're going to do by calculator. Anytime we have a 2 by 2, know that you have to do it by hand. When we have 3 by 3s on your test, you can use your calculator for that stuff.